All right, so there has been a lot of buzz on Bitcoin Twitter about things like rollups and zero knowledge proofs and BitVm, all within the context of scaling Bitcoin. So I wanted to make this video to go over whether ZK rollups on Bitcoin are possible, what are the potential limitations, and then at the end, discuss the benefits. That way people can kind of decide for themselves, is this a worthy idea worth pursuing, or is this some scaling solution we should just throw in the trash can? The punchline, if you don't want to watch the rest of the video, is that without any sort of soft fork whatsoever, we can probably get, I would say, 90% of the way to a true ZK rollup on Bitcoin. And that means that we could have a solution that is far more powerful and more robust than the existing solutions. And while it's not perfectly 100% cryptographically trustless, it would be what we would call trust minimized. And this is something that, again, is not perfectly cryptographically trustless, but is far better than the pre-existing solutions. That should be kind of good enough to allow us to cross the chasm to build out this more robust roll-up ecosystem. So that's kind of the background. Now we'll kind of go over a timeline here of the relevant events, and then we'll discuss a little bit about just normal Bitcoin, which everybody should be familiar with, and then how side chains and then eventually roll-ups work with all the limitations. So first things first, some timeline background. Pre-2013, you start seeing conversations on places like Bitcoin Talk Forum with Satoshi and Greg Maxwell and Eli Ben-Sasson and other people talking about how they can use ZKP's zero-knowledge proofs to scale Bitcoin. Up until now, a lot of people understood them as a privacy tool, but not necessarily a scaling tool. For people that aren't familiar, a zero-knowledge proof is some way to prove the validity of some sort of information without revealing the underlying contents. So for privacy, it's like I'm proving that this payment is valid, but I can't divulge the amounts and the receiver and the sender, etc. You can use that same kind of premise, this idea that you can prove the integrity of some sort of computation without making somebody redo or recompute all the computation. And that's how you can use it for scale. In 2014, we got sidechains. This was the white paper that Blockstream released where they said, we're gonna have, the Bitcoin blockchain L1, we're gonna have all these separate side chains, all these separate blockchains, and some are gonna specialize maybe in privacy, some are gonna be, big blocks and fast transactions, and you'll be able to bridge your Bitcoin into these other ecosystems and get the benefit of those applications without altering the L1. This was, in theory, a very cool idea. The problem is they didn't solve the trustless two-way peg. They said anytime you want to bridge into these other ecosystems, you essentially have to go through our federation, and then you have to trust us in order to bridge your funds out. In my opinion, that's one of the main reasons why sidechains didn't take off. I also think that they were just ahead of their time. They were kind of built out before any useful applications really existed. In 2017, we had a soft fork on Bitcoin called SegWit, or Segregated Witness. The intended consequence of SegWit was to fix something called transaction malleability, which enabled Lightning Network. The unintended consequence, which we found out in the past year, is that it enabled things like ordinals and inscriptions. Essentially, SegWit carved out a section of the Bitcoin block. It segregated a portion of the block and calls it the witness. And within that section, you can essentially put arbitrary data. And that's why things like the JPEGs and a lot of the BRC20 and other things that people don't really like can exist now within the Bitcoin blockchain. But SegWit, that area for the data, will be very important for building rollups. In 2019, rollups on Ethereum, the first one was actually issued. At this point in time, Ethereum community had looked at a lot of other scaling solutions, things like state channels, which are kind of like Lightning Network with smart contracts. They looked at Plasma, they looked at a bunch of different things, but eventually they settled on rollups, and they said, we're gonna pivot our entire roadmap for scaling solely to be around this like rollup centric roadmap. In 2020, another soft fork came, which was Taproot. This is my bad attempt to build a Merkleized abstract syntax tree. It's just a binary tree. You don't need to know what it is. It's just a way to organize and structure cryptographic data so it's easier to work with. In 2023, Robin Linus released the white paper for BitVm, and the claim here is that with BitVm, you can now compute anything on Bitcoin, which is like a very, very bold claim because it was always assumed that you couldn't do expressive computation, things like Turing complete contracts on Bitcoin. So what is happening now in 2024, and I believe beyond, there's going to be big conversation on ZK rollups on Bitcoin. Can we do them, and is it worth it? And so to recap, essentially what a rollup, a ZK rollup on Bitcoin would look like is it's just a side chain that takes its transaction data plus a zero knowledge proof and it posts it inside of the parent blockchain, or in this case, Bitcoin is the layer 1. And it does that by posting it into the segregated witness section of the block, which was originally enabled for Lightning and that is now being used for inscriptions. It posts that data inside the block. Then that zero knowledge proof that you posted in the segregated witness is verified by BitVm, which uses Taproot. And when you combine all that together, you effectively get a ZK rollup. So we'll kind of walk through all of that right here, and then we'll fill in a lot of the boxes as we kind of go so people can see how this actually works. To recap the basics, we have Bitcoin up here, anything above the dashed line, and then anything below this line is the, what we'll start off as the side chain, and we'll kind of evolve into a rollup. So basic Bitcoin transaction, Alice sends 1 Bitcoin to Bob. This goes into the mempool. The mempool is effectively the waiting room where the miners are doing their proof of work. They solve they solve the proof of work, and then they get to create a block. They're taking transactions from the mempool, placing them in the block. The block is then going out to the nodes. The nodes check to make sure the block's in consensus, meaning it's the right shape and size and has the right proof of work. If it is, they append it to all the prior blocks in the blockchain. And then they actually go through the process of they'll look inside the block and they'll look at all the transactions and then they'll actually validate them. They'll say, does Alice actually have a proper signature in order to send these funds? Does Alice actually have sufficient Bitcoin, etc. Within the block also, there's not just transaction data, but there's this separate section within the block, which is what we're calling the witness, this kind of carved out section where you can embed other arbitrary data into there. So once the nodes have validated the transactions, you would have the UTXO set, which is kind of the balances of whatever everybody has for their Bitcoin and who has what. So here you could put, let's say Alice has 4 Bitcoin now. And let's say Bob has 1 Bitcoin after they conducted that transaction. Okay, cool. So now let's talk about where a sidechain comes in. Let's, instead of saying that Alice and Bob are each holding 4 and 1 Bitcoin on layer 1, let's say that they put it into a multi-sig together. So we'll say multi-sig here, and there's 5 total Bitcoin in this multi-sig. Alice put 4 in, Bob put 1. And we're going to represent this multi-sig or this UTXO right here in this box. And so we're going to say 5 Bitcoin exist on the layer 1, but then also the side chain, in order to operate on the side chain, you're minting 5 of these, what I'm going to call RBTC, just for rollup BTC, and this other ecosystem. So up here, locked on layer 1, up here they're kind of free floating as like IOUs that you can exist in this layer 2 environment. So what would happen then is Alice and Bob, they move their coins over here because they don't want to be constrained by the Bitcoin layer 1 environment. Bitcoin script doesn't allow you to kind of have this full level of expressivity and smart contracts and some of these other features that some of these other chains have. So let's assume that they take some of their coins and they're going to do some sort of computation with it. And over here, because you're no longer restricted by the Bitcoin layer 1, you can do any sort of programming language you want. You can do Ethereum's language, which is like Solidity and the EVM. You could do Rust, you could do Cairo, you could do Clarity, you could do whatever you want. And there's also no kind of limitations on, we're just using channels like in Lightning, so there's a restriction on what type of applications you can build. Like you're just totally free in this kind of sidechain world. And so I put up a few random use cases. Maybe people want to do some DeFi, maybe they want to do fully encrypted privacy transactions, they want to do stable coins, they want to use liquidity pools, account abstraction, really anything that people want. So then as a byproduct of performing some sort of computation on this layer 2, you get essentially 2 things. One is you get an updated state. So here, Alice and Bob, they did a bunch of transactions, and maybe now Alice has 2 Bitcoin, and let's say Bob has 3 Bitcoin. And then you're also going to get some transaction data here as a byproduct. So from this computation, you're going to get some transaction data, and then you're also going to get you're going to get an updated state. Now, once there's an updated state here, Alice and Bob are both wondering, okay, how do I have assurance that I can actually get 2 Bitcoin on the layer 1 and Bob can get 3 Bitcoin on the layer 1? And fundamentally, getting this updated state up to the L1, in my opinion, is the Oracle problem, because the Bitcoin layer 1, it cannot understand any information outside of itself. Other blockchains could run a Bitcoin node and they can see what balances other people have, but we don't want to put that burden on the Bitcoin nodes to say, hey, you have to go out and run all of these other blockchains nodes, which could be, bloated and massively inefficient. Like, the whole point is to keep Bitcoin, lean and kind of restricted. So this problem is fundamental to understanding rollups and sidechains, because in a normal sidechain type setup, or really any solution, you're going to have to take this state, and some party right here is going to have to relay this information up to the multi-sig. And again, we'll put multi-sig up here. And they're going to have to relay this information up, and they're going to have to manually make these adjustments. So in some ways, in basically every way, you're trusting this party, to be honest, to take this state information and then relay it up here. And this could be, if you have wrap BTC on Ethereum, you're trusting BitGo. If you have LBTC on Liquid, you're trusting the Federation members, Adam Back and all those guys. With RSK, same thing. With drive chains, it's the same thing, except you're trusting the miners. And someone like Paul Storks would say, well, it would take 3 months. The miners would have to steal out and open in public, and they would never do that because it would just be bad, game theory. And maybe he's probably right, but the fundamental idea is still you're relying on some sort of permission party to make this change up into the L1. And so the potential solution that Rollups came up with to solve this idea, they said, instead of having a singular permission party where we say only this party can move these funds and we're going to trust them in order to do that, what if we said anyone can update these funds? Anyone can change the balances within this multi-sig, but they have to provide validity. They have to somehow mathematically prove to the layer 1 that the updated state that Alice now has 2 and Bob has 1 is mathematically valid. And this is where the idea of a zero knowledge proof comes in. So we're going to put a ZKP right up here. And what does a ZKP do? You could think of it as like an unforgeable digital receipt, where in this case, you can create a succinct proof that says things like no more than 21 million coins were created by getting to this state. So if Bob now had 4 Bitcoins, and that would be 6 total, that's invalid because you only put 5 in initially. Or something like the order of the transactions actually occurred in the right order. Or things like signatures, like Alice and Bob actually did in fact sign off on doing all of these transactions. And so with this now zero knowledge proof, you can mathematically prove that all this computation that had over here to get to this state was actually valid. And so to prove a point, we could say in this person right here, let's say it's Fake Toshi. Fake Toshi is very evil. They want to steal, all of your coins. And so they're trying to update this multisig to say Fake Toshi actually has 5 Bitcoin. Alice and Bob have none of them. But if you now need this zero knowledge proof in order to move these funds, then Fake Toshi can do nothing. They can only ever submit a valid state. It is impossible for them to submit any sort of invalid state. So now this is like a very potentially beautiful system, because what would happen is the state gets updated with the zero knowledge proof, and let's also say that the transaction data is being sent. So you're sending the state, the transaction data, and the zero knowledge proof up into this multisig, which is then spent, and then this goes back up into the mempool. And because you're earning fees or people are paying fees, cheaper fees, but down here, you can batch together all these transactions, and then you can pay a single fee into the mempool. The miners mine, all of this stuff goes into the block, but it goes in specifically into this witness section of the block. And what would then happen is, because there's a ZKP in here, a zero knowledge proof, the Bitcoin blockchain would look at that and it would say, okay, check. I can verify now the validity of this statement. And the Bitcoin blockchain would you think of it as saying, Bitcoin says, look, I don't care what you did down there. Like I'm not making any judgments whether you did, NFTs and DeFi or whatever. Just prove to me that you followed my rules. And if you can prove that, then the Bitcoin blockchain says, cool, you're fine to update all these balances. So to be clear, the nodes aren't actually going through and validating every single one of these transactions. They're not going through and looking at, was this DeFi transaction valid, et cetera, et cetera. They're just looking at the entire batch and saying, was the entire batch within the kind of rules that we want Bitcoin's consensus to follow? Okay, so this setup right here is what I would call like a perfect world ZK rollup. One that, if we didn't have to worry about soft forks and we had all the functionality we want, like this is how things would work. So we put it here as ZK rollup trustless. This structure is technically not possible. And that's why some people on Bitcoin Twitter are saying that ZK rollups are not actually possible on Bitcoin. So we'll dive into that. There's two primary reasons why this setup is not actually possible on Bitcoin. The first, and probably most important, is this part right here that I skipped over, that Bitcoin is just going to be able to verify the zero knowledge proof that was submitted. Bitcoin can't verify zero knowledge proofs. So that right there seems like it kills the idea. The second thing right here is I said that we could kind of put this constraint on the multi-sig and say that, you can only move funds in the multi-sig if you have like a validity proof. What I described there is essentially a covenant. You're taking a UTXO and you're constraining, or you're restricting where the UTXO can be spent. You're saying, I'm restricting it to only be spendable with a validity proof. So right here, you would need a soft fork of covenants, maybe even like recursive covenants. And over here, you would need like an opcode to verify ZK proofs. Where things change and get really interesting is with the introduction of BitVm. So I'll just kind of put it up here. BitVm. So the claim of what BitVm could do is that you could potentially hack in a way to verify ZK proofs on Bitcoin. So now, if we had that, all of a sudden we can verify that this data here was actually valid. And so we can get across that hurdle. If you then have a ZK verifier, while you can't have covenants without a soft fork, you could probably hack in some sort of functionality where you say, hey, we have a multi-sig, and any party in that multi-sig can spend it if they do have a validity proof, which can be verified by BitVm. So BitVm kind of allows us to maybe bypass some of these previously thought constraints that we could only get around with a soft fork. The caveat with BitVm, there's a couple things. Is one, it's a bit clunky and it's a bit inefficient, but mostly it has what's called like a 1 of n trust assumption. And I won't go into the details of how BitVm works, but if you imagine that there are, let's say, any number of participants that are part of this BitVm computation, it could be 5, it could be 10, it could be 100, it could be 1,000. And you only need one participant in that to be honest in order for the BitVm program to work. So if you have 100 parties that say, I'm going to verify, or I'm going to perform this ZK verification that you need for these rollups, if 99 of them are lying and only one is honest, then it will still work. So is it perfectly trustless? No, but is it pretty dang good? Yes. And eventually you can get to a structure where you yourself can be one of the parties that are performing this computation. So you don't have to trust anyone aside from yourself. So again, not perfect, but like very good trust assumptions. So we'll put 1 of n here. So that gets us to our second rollup. And this is the more realistic type of ZK rollup that can be built on Bitcoin. What I'm going to call a BitVm ZK rollup. Not perfectly trustless, but trust minimized. Okay, so if we accept that with BitVm, this is technically possible, then we now have the basic structure of a BitVm style ZK rollup. And this is kind of what's getting people excited, and they're saying, whoa, okay, like we could probably hack together some sort of ZK rollup. This is enough for us to cross that chasm and get into this world of everything that rollups could offer for scaling. So now we can talk about the main limitations of rollups, even though they are actually possible. The primary one, which I skipped over, is going back to fake Toshi here. So I put fake Toshi here, and this could also be called the sequencer. One of the benefits of rollups is you could have a singular party. You could have a hyper-centralized, person running Amazon web services with everything parallelized and super optimized, performing all of this ZKP and state updates and transaction data. You don't need to create all these different nodes in this fake consensus. You could just have one party and be super efficient to process all these transactions. And because they can't lie, because they have to submit a zero knowledge proof, like the fact that you can make it just like very centralized as sequencer, but they still can't steal, that's part of the scalability benefits. But, if you have somebody who's a sequencer and it ends up being, fake Toshi, and they're like, well, I don't, I'm just gonna be an asshole and I don't want to steal the funds, but I want to screw everybody else over and I want to freeze the funds. So it's not that they're able to submit an invalid state or steal the money, but they could just say, well, I'm just not going to do anything. I'm not going to submit any sort of transaction. So everything just freezes. These Bitcoin are essentially stuck in the transaction and everybody's screwed. The way to get around this, if you remember, is that we didn't just say that fake Toshi or the sequencer is the only one that can update the state. But what we said is that anyone can update the state as long as they have validity, as long as they have a zero knowledge proof. So what somebody could do is you, as the user, you could submit a zero knowledge proof. And so if we said fake Toshi is no longer submitting this information, and we said that the user is doing this, then you can kind of unilaterally update this state, or you could what we call unilateral exit. So if you are Alice and you say, I want to get my 2 Bitcoin out, you can create a zero knowledge proof, prove that this is the valid state, and then you could withdraw your funds. The issue with this is that in order to create a zero knowledge proof, you need the data. And so if you don't have the data, then you can't create the ZKP and you can't go through this process. And this is fundamentally what people criticize most about rollups is the data availability problem. How can you ensure that the data is always available somewhere so that users, if the sequencer goes rogue, so that users can always create these zero knowledge proofs? And the way that's done is the transaction data, if you remember, which I put down here, was always being submitted up into the Bitcoin blockchain, and it was being posted in this inscriptions part of the block with the zero knowledge proof. And if all of this prior data from all these transactions that have been going on the rollup are on our Bitcoin nodes, then it's much easier to access. That's the only way you can ensure that data is available, if it's posted on the kind of most robust, longest lasting, Bitcoin blockchain. So if a user has a BTC node, if they have a Bitcoin node, then they can access all of the data to recreate the state and create a zero knowledge proof and update everything in this process. Realistically, what would probably happen is some honest actor in the community would say, okay, great, like I'm just going to open up the node, they're going to extract out all of the data, and they'll process a batch transaction for everybody to go ahead and advance the state or unlock all of their funds in the rollup. But the key idea here is that a user, in theory, has everything that they need to be able to unilaterally exit without depending on anyone. Okay, So then the next part to kind of go over is somebody would say, well, okay, if you have to post all of this transaction data onto the Bitcoin L1, that seems dumb as hell, because if you have to post all of this, like there's only so much block space in the Bitcoin blocks. Like you're either going to run out of block space or the fees are just going to skyrocket, and it essentially won't be very scalable. It won't be very cheap to operate on this L2 because you're having to pay for these obscenely higher fees on the L1. So there's a couple things to note here. One is you're not technically submitting to the L1 the pure transaction data. You're submitting what's called state diff. So a state diff, you could think of it basically like if Alice and Bob send 100 transactions back and forth, but the difference is only one Bitcoin, then that is the state difference. Like the transaction data would be all the actual individual transactions. The state diff is just the singular net change of all of the transactions that occurred. And so because of that, you are getting a modest data compression effect on what you're submitting to the L1. So I'll try to do like a little compression thing right there. And you're submitting less data to process transactions than you otherwise if you just did it through the Bitcoin blockchain. You're also getting the benefit of being able to do other types of transactions that you can't do on the Bitcoin blockchain. So let's say with state diffs, it kind of depends on what type of activity you're doing on the L2, whether you're doing DeFi or basic transactions or private transactions, but maybe you can get anywhere from like 10 to 40x scaling improvements. So again, even with this type of setup where you want to make sure that you post all the data on chain for top amount of security, and you want to make sure that that you can get around the sequencer going rogue or malicious, you're getting about 10 to 40x scaling improvement and all the expressivity that you can get on the layer 2. A lot of people would say, well, that's still stupid because we need orders of magnitude more scale in order for Bitcoin to essentially work. And so 10 to 40x, well, hey, it's good, it's cool, like that pales in comparison to essentially what we need. Then after that, we now get into this area of what I'm going to call, or what other people have called, and I'm stealing their language, a validium. And so this is a type of rollup where you don't post the data on the chain and you post it in other off-chain environments. So I'm going to put right here, off-chain DA. And so the question becomes, all right, if somebody says, hey, I really like this whole rollup setup, I like that everything settles into Bitcoin, I like that it has this kind of trust minimized bridge with BitVm, I like all the applications, but they say, I want cheaper transactions, I need more scalable transactions, I can't be paying these high layer 1 fees. So they could go and they could post their data on Ethereum, they could go and post their data on Solana, they could go and post it on a federation that exists. Maybe somebody creates like a spider chain, which is a new alternative Bitcoin layer 2, and creates a DA layer there. Or somebody could go and they could post it on their own computer. If they say, I don't trust any of those other chains, I just want to post it on my computer. And the fundamental issue here is you have this now menu of kind of options where you could say, hey, I'm cool with Ethereum. I trust that their data is going to continue to exist and it's much cheaper there, so they can post it there. Or somebody again says, well, I don't trust any other blockchain aside from Bitcoin itself and my own personal self. So they would just post it directly locally on their computer and they would store their own data. And with this, now if you no longer have to put all of the data onto the Bitcoin L1, you kind of get into this world of potentially infinite scale. The issue, which some people used to have with rollups, but is now being solved, is how can all of these different data availability options interact with each other? How can they cross-compose and they can share liquidity? if I want to operate in the model where I want the Bitcoin security on the layer 1, but somebody else wants to operate in the Ethereum system, can we trustlessly compose with each other? Can I send a transaction to them, or do I now have to bridge my funds into the Ethereum ecosystem? And the answer is no. With the power of zero knowledge proofs, the interactions between all of these become trustless. And you can see, I think, hopefully from this whole conversation, why it's so difficult to discuss rollups. Because it's like, well, can ZK rollups be done on Bitcoin? It's like, well, no, the trustless kind technically can't be done, but we can do these like BitVm ZK rollups. And then somebody will say, well, the sequencer is centralized. It's like, well, yes, but you could technically unilaterally exit if the data is stored on the node. And then somebody says, well, okay, but then, the fees on Bitcoin L1 are going to be so high, so you need to post it off chain, and then everything breaks down. It's like, well, sure, but, each person can pay for whatever level of security they want, and everybody can interact, together on these chains. So this vision for rollups, it just offers so much flexibility and so much potential power without actually altering the Bitcoin layer 1. And one other thing I just wanted to mention is if we do go this route of a rollup on Bitcoin, we're not adding any sort of Turing completeness to the Bitcoin blockchain. You're not increasing the block size. You're not changing the rules of consensus at all. You're not increasing the validation costs of the nodes. You're really simply you're posting arbitrary data in the block in the same way that inscriptions would. And then you're simply just saying, is the mathematical proof that I received, the zero knowledge proof, is it valid? If yes, true or false. So it's a very benign, it's not even a change to Bitcoin, but it's a very benign way to add hugely robust and powerful features to Bitcoin. Okay, I think that covers most of it. I wanted to go over some of the benefits, and then people can kind of decide, if they think it's worth it. So the first one I would say is UX. With this rollup type setup, and especially with this cross composability DA stuff, it's you essentially just open up a wallet, you can immediately start receiving funds. You can immediately start, sending funds. You could have, an account abstraction wallet where, some provider like Coinbase is saying, look, we'll automatically pre-fund your wallet to cover all of your transaction fees. There's just tons of flexibility here that things like Lightning doesn't really offer. Lightning Network, Ben DeCarmen wrote that Stacker News piece where he kind of described all the problems with Lightning and how clunky it is. In my opinion, it doesn't really matter what sort of soft fork we get to solve Lightning. There are just systemic issues that make it incredibly difficult to operate. So UX, number one, gold standard. You could have the best UX possible with these types of rollup structures. The next point I would say is there's no token. For some people, that's a very big deal. None of this process requires any sort of external token to build out the infrastructure. Now, will people try to issue tokens because you have that ability to program that? Yeah, people will probably do that. Will somebody try to say, hey, we need a token to decentralize the sequencer? Yeah, people could probably do that, but do you fundamentally need one? Absolutely not. Bitcoin is the token. I mentioned this a bunch, but the programmability, things like Lightning and Arc, they don't really have programmability. You can just do payments, and for some people that's good enough. But in my opinion, there's clear use case for some very legitimate, non-gambling, speculative use cases that you need this kind of programmability for. The next thing, which is kind of related, is global state. In Lightning Network, you have this kind of channel topography where you have all these kind of pockets of liquidity that are isolated from each other, and that works fine for routing payments. But because you don't have a global state, you're hugely restricted on the type of applications you can build. In particular, you can't create what are called liquidity pools, where you have a bunch of users that pool funds into one contract, and then maybe you can use that liquidity pool to borrow and lend from, or to create an AMM. You can only do them in kind of these very inefficient and hacky ways on Lightning. So having global state, huge. The next one is scale and flexibility. I kind of talked about this a bunch, but a lot of the scale comes from one, the zero knowledge proof, which kind of proves the validity of all this stuff happening off chain. But then you have this compression technique that comes from the state differences being posted, and then the off-chain DA. So in theory, like you could reach, end game scalability where scale isn't really an issue whatsoever. And then flexibility as well, I'd also kind of discuss. This has like total flexibility to build out in kind of any way that you want. Network effects, I think this one's huge. So whether we like it or not, in all of these like non-Bitcoin communities, there are tons of developers that are building things. And we want the ability to bring all of that back, to not infiltrate the Bitcoin layer 1, but to be able to build onto these layer 2s in these different applications. And the fact that you can use EVM, the Ethereum programming language, the Ethereum virtual machine, if you want, or you could use Rust, or you could use Cairo, you could use Clarity. Like you just immediately tap into all these different networks. There's even teams that are working on the ability to build in JavaScript, and so it just opens up the door to pretty much like every programmer on the face of the planet building for monetary maximalism. The next one is economic density. So a lot of people are getting really pissed off that people are posting JPEGs and BRC20s like in this inscription section. And I'm not going to take a stance on like the filters or whatnot, but a more pragmatic solution is just saying that essentially all those people are going to run out of money. Block fees are going to go up higher. They're going to say, well, hey, screw that. I'm not willing to pay to put my monkey on the Bitcoin chain, and we'll just stop. Rollups really are the kind of solution to that, because they can create economic density. You can do all of these transactions down here on the layer 2, and you can batch it together and take the fees from a mass amount of transactions, and then you can post this data, which can be all monetary transactions. It could be transfers, it could be DeFi, it could be privacy, and you can post all of that, and you will essentially price out the ordinal enjoyers. And I think that kind of goes along with this idea that like everyone is expecting fees on Bitcoin layer 1 to go up. Like the amount of block space on Bitcoin L1 is so freaking tiny that at any modicum of global scale, the Bitcoin blocks, just with people like every once in a while, once a year or twice a year, like submitting some sort of transfer or going into cold storage or doing a settlement, is going to already fill up the blocks. If your scaling solution that you like does not operate well into high fee environments, then you need to reconsider. And I think that's one of the major problems that we're seeing with something like Lightning Network, is how much the on-chain footprint constantly hits the Bitcoin blockchain, and how much that really makes Lightning Network suffer. So you need a scaling solution that can benefit from economic density and posting that to the Bitcoin L1. The last point, which is upgradability, which I'll talk about. And this is kind of like creating a full stack of fully decentralized applications. A lot of people will look at smart contracts and they'll be like, oh, smart contracts are bullshit, they're not actually decentralized. And I don't think they actually understand how that works. The reason they're saying that is on a smart contract, it's like a normal, Bitcoin on the layer 1, where there's a key, there's a private key that you can plug in and you can access that smart contract. And this is how the engineers, create the smart contracts, and then they edit them in order to build them out. But because they have that key, they could just go in and unlock the code, and they can change all of it, and then they can rug pull everybody. And so a lot of people will claim it's like these smart contracts on Ethereum, they're not actually decentralized because somebody can go in there and rug pull it. But what you can do, and they do this on Ethereum on a few applications, is that they've actually burned the contract upgradability. They say, this contract has gotten to a robust enough spot where we feel good about the code, and we're going to burn and throw away the key. That is an amazing, amazing step towards actual true decentralization, where you can interact with a protocol and know this thing can't be changed or rug pulled underneath me. However, where it could be potentially changed is if Ethereum, the foundation itself, can be forked or can be changed. Then if the underlying the underlying blockchain can be forked, then you can reverse any of those upgradabilities that were burned. With a rollup that's built on Bitcoin, you can create a protocol or an application like a borrowing application. You can build it onto the rollup, which then settles onto the Bitcoin layer 1. And because the rollup itself inherits its security from the Bitcoin L1, it cannot reorg independent of the L1 itself. It cannot really fork unless Bitcoin itself forks. So if you have these applications that are built on Bitcoin rollups, you could have the entire full stack being decentralized, where you have the contract, the upgradability is burned because that settles into a rollup, which then goes into Bitcoin L1. That's like this kind of beautiful permissionless vision that I have for Bitcoin. So we're getting to the end here. For me personally, you probably tell like I'm a little biased, but I think rollups for Bitcoin are going to be a revolution. I think that despite them kind of being originally innovated by the Ethereum community, I think that they're going to be far more impactful for Bitcoin and Bitcoin's revolution than they ever would be for Ethereum. And I think that over the next 10 years, you're going to kind of see a role reversal, where in the prior 10 years, a lot of Bitcoiners were kind of coping and saying, oh man, like you guys don't understand scaling, like Greg Maxwell and so-and-so already talked about this back in 2013, and then they'll link to some post saying, oh, we already talked about zero knowledge proofs, like Bitcoin's been there, done that, we've already researched that. And I think moving forward, we got to give Ethereum some props here, because Bitcoiners are going to be like, holy shit, this roll-up roadmap is badass. And over the next 10 years, people are going to be like, Ethereum people are going to be coping and saying, oh, well, like, Vitalik and Justin Drake, like all these people already talked about that issue in 2023. And it's like, well, great. Yeah, thanks. Like you guys just built out this like amazing scalable, infrastructure for us. Like, we're adopting it on Bitcoin. And I think you're going to start bringing back that kind of ethos of like anything good that happens on other chains, we're going to bring back to Bitcoin. The final thing I'll just say is whether people agree with this roadmap or not, the can of worms has kind of been opened. Because of BitVm and this ability to kind of create this one event trust assumption, you can now hack together all of this. So these rollups are potentially coming. And I think everyone will benefit from that, but if you don't like it, it's gonna be hard to stop. All right, so hopefully that video was helpful. I'm sure a lot of people will be looking at this like, what the hell is this guy talking about? And that's totally cool. If you wanna ask questions or I can do a follow-up, I'm happy to. Thanks.